Yeah, so hi everyone, and welcome to our first meeting of this student chapter. So our idea is to, well, you Mateo are a bit more aware of this, but our idea is to make timber and every topic related to wood more accessible for students throughout Australia. We've been trying to set this up for a while now. It's so far it's been just the work hours of a couple of students and Kelly's and Louis, which are scarce because we're PhD students, and the idea is to engage more with students because basically they're going to be the future workforce and the future researchers, and it's good to include them from the beginning and know where we are at and where we are going to be and where we want to be as a timber industry, timber researchers, timber professionals in general. So our idea is to have meetings and to have different hubs around Australia in the different universities. Gathering students and all, and also get all this input from industry, how things are done, how things are going to be done, and what's the situation now. So I really appreciate having you, Mateo, presenting about AKD, what you do, and what the future is looking like.
All right, well, thanks, Thomas. So do you want me to start the presentation now?
Yeah, sure. Will you have time for Q&A after the presentation?
Yeah, no, I have already set aside 1 hour, so after the presentation we can have some Q&A and yeah, maybe a broader discussion about what I presented. So no problem with that.
Perfect then. So for the people who are here who don't know Mateo, he used to be a student at UQ, and now he's a successful professional working in the timber industry, which is, so he's the poster boy of what we want to achieve in the future. So go on, Mateo.
Well, thanks. I'm not really sure about the successful part, but I do work in the timber industry, which is definitely one of the goals of the society. So yeah, again, thanks, Thomas, for the introduction, and thank you, Luis, in particular, for having me today, but also obviously Kelly, Josh, and the guys at UQ. As you said, I'm a UQ alumni, so I'm very proud of that, and I will be more than happy to contribute, anyhow, with the successful future of not only UQ students but students working with timber in Australia. So yeah, thanks for having me. So again, my presentation today it's an introduction to structural timber and what we consider the ideal material to achieve net zero. So this is not mainly focused about sawn timber, which is what AKD currently produces, but I try to do it as general as possible because Luis asked me to cover many topics where we believe, timber students can work in the future. So I try to do it very general. So first of all, well, as you guys already said, I work for AKD, AKD Softwoods. It's an Australian-owned business. It's a vertically integrated business, so we own softwood plantations across Australia in different locations. We have different sawmills located across the East Coast. In those sawmills, we produce different timber products from wood chips, and we export wood chips up to structural timber products, but we also produce green case and other materials that can be used in packaging. But obviously, our main concern is structural materials. Obviously, I'm a structural engineer. My role in the business is working with our clients and our customers and end users as well of our products to see how can we better utilize the fiber. We know Australia is a resource constrained country. We know that we have had timber shortages before, so we just want to make sure that we are using that timber correctly. So part of my presentation today will be explaining the way that we process our timber and how do we use it, what are the implications of the material properties and the material characteristics in the overall performance of those products, and then probably suggesting some of the future pathways that we need to take in order to improve the use of the material and improve the performance of the material. So as you can see on these videos, AKD pretty much received the logs at the different sawmills. So the sawmill where I am today is in Colac, Victoria, like around 2 hours away from Melbourne. But AKD also have other sawmills in Queensland, Caboolture, located like 1 hour and a half away from Brisbane, where we also produce structural timber, and Tumut in New South Wales, around 4 hours away from Sydney, and we also produce timber there. But we have other locations like Yarram and Port Pine, and also Oberon in New South Wales. So after timber is being cut and is being graded at the green mill, timber is kiln dry and then goes to the dry mill where it's graded and then finally packaged and sent to our customers. But I will go through that later. So which is what you are currently seeing in that video. So again, the content of my presentation will be some timber fundamentals, then and obviously understanding the characteristics of timber and what will be the impacts of those characteristics in the end products. What are the main structural systems where we use timber, especially light timber framing, which is where our all products are being used. But I'm also give you a brief intro on engineered wood products, systems with engineered wood products, and some future needs. So in terms of timber fundamentals, and I gave the presentation the title of the ideal material to achieve net zero targets. It's because we know that timber sequesters carbon. A lot of that carbon is used in the production of wood, of course, and we know that around 50% of the dry weight of wood it's equivalent to the carbon removed in the atmosphere. And so to produce a structural sawn timber, we relatively use very low energy, and it is also important to understand what's the biogenic carbon, because this is very common terminology that we use these days. And again, I'm not an expert on this. I'm a structural engineer, but I'm aware that this will have massive impact in the future, especially with those zero carbon targets. Biogenic carbon is all the carbon that is produced and stored by the trees. So this is what makes timber carbon negative. So let me just turn on my pointer. So you have carbon emissions produced during the manufacturing or production of structural timber, but because timber sequester carbon during the growth of the trees, the end number is a negative number. So Wood Solutions actually just published like a very complete data set or database with different timber products and the carbon emissions and EPDs from all those different products. So I would recommend you guys, if you're interested in this topic, to take a look at the Wood Solutions website. So for those that are not familiar with the sawmilling process or the process to produce structural sawn timber, So as I was explaining before, so we get the logs at the sawmill, we sort those logs into different groups, and then based on the diameter and the properties of the logs, and then we run the logs through the green mill, where we cut it into green boards, and then those boards are stacked, and then they're sent to the kilns where they are dry, and then after the material has been dry to a moisture content of around 12%, then the material is run through the dry mill, where we trim those boards, grade those boards, and trim it to the final, and obviously dress it as well to the final dimensions. So this is a very important process, the grading process, and I'm gonna expand a little bit more on that. And then finally, the material is being packed, grabbed, and sent to the end users, which could be, you know, stick builders or frame and truss manufacturers, or even other factories that can produce engineered wood products based on those boards. So it is important that we understand some of the basic concepts about the anatomy of a log. Because when we cut timber, those properties are going to affect the performance of the material. So we know that obviously a tree has a softwood and hardwood, and that we have fibers that are oriented longitudinally across the log height. And then obviously when we cut that material that is that it has a circular shape, we're going to end up with some rectangles, and obviously those rectangles are going to be affected by the growth rings of the log. We know that the center of the log, usually where the juvenile wood or the pith is located, has a low stiffness, and then the outer part of the log, where the sapwood is, we're going to have higher stiffness, higher density, and therefore better mechanical properties. So this has an impact not only on the stiffness and the mechanical properties, but it will have an impact on the preservation of the material and the effectiveness of those preservative treatments as well. Kiln drying is another very important process, because timber is highly dependent on the moisture content. We know that timber has or suffers dimensional changes below the fiber saturation point. So we want to make sure that the timber moisture content is below the fiber saturation point, because we want to reduce those dimensional changes, but also because the mechanical properties change with moisture. So the lower the moisture, the higher the strength and the stiffness in the material. And obviously that moisture content will depend on the environmental conditions where the timber is being stored and being used. So we use tables like this one to calculate the equilibrium moisture content of the wood, and what will be the impacts of that moisture content in the properties. Another thing that is very important is the direction of the fibers. So as I mentioned before, the fibers are mainly responsible for the strength of the material. We know timber is very strong when we apply loads parallel to the fibers, and it's quite weak when we apply loads perpendicular to the fibers. So understanding the orientation of those fibers and the impact of different features like knots or holes will have on those mechanical properties is quite important for us. And that's why we have the grading process, because through the grading process, we use some primary properties like the stiffness or the density to predict the strength of the timber. So knots that may affect the orientation of the fibers, or that may reduce the cross section of the timber pieces, will have an impact on the strength of the material. So, and that's why we have strength grading or stress grades, which is pretty much having different groups of timber that have similar characteristics. There are different ways of doing stress grading. The most common one are visual grading, and the machine graded. At AKD, we only do machine grading. So we use cutting edge technology to determine the properties of the boards and to predict the stiffness and the strength of those boards. When we grade timber for strength, we use what is called the characteristic value. So if you have a population that will have a range of properties, we use the 5th percentile to describe what will be the characteristic strength of that material. So we can guarantee that 95% of those of that population will have properties above the value that we have declared or considered. Whereas for the stiffness or the MOE or modulus of elasticity, we use the average value. So we know that around half of the boards are going to have a MOE or modulus of elasticity above what we have considered the declared value, and the other half is going to be actually below. So in this curve here, you can see that this is the whole population. And then once we establish those grades and establish those thresholds, we sort of segregate the different groups that we have. So as I've already mentioned, we have cutting edge technology to do this grading process. So as you can see here on the left-hand side, we have the scanner, which uses a combination of different sensors, like, for example, X-ray or a triangulation of cameras. We also use lasers to determine the dimensional properties, and then based on those properties, we can segregate the different groups. We also use vibration or acoustic grading equipment, which is a very accurate method to measure modulus of elasticity. So this is pretty much a hammer that is hitting those boards while they go through the sawmill. And then the hammer creates a vibration in the board, and then we measure that vibration and we create a profile of the modulus of elasticity based on that vibration. And then we use other supporting equipment. We use scanners to measure the moisture content. We use other scanners to measure the distortion on the boards, by taking photos and using lasers to see those dimensions. We can establish which boards are out of the tolerance of our, different thresholds for bow and spring and bow, spring, and other sort of distortion twist as well. So we are capturing data all the time, and then we use this data to sort of monitor the gradings that we are producing and understanding the characteristics of the resource that we are producing, and see how do we adjust those thresholds to make sure that we are always compliant with international standards, and making sure that our material is meeting the needs of our clients. Another process that is very important as well at the sawmills is the treatment. We offer different treated products to different hazard classes, H2, H2F, H3. So we are also, doing permanent monitoring on the effectiveness of that treatment, and making sure that we comply with Australian standards and other regulations. And again, to be able to do all of these, we have a very strict quality management system where we verify the properties of our boards. So we need to take samples in every run and in every batch, and we need to actually test those boards and make sure that we all the density, strength, MOR, modulus of rupture or bending strength, and stiffness, modulus of elasticity, it's actually that we predict with our scanners and other equipment. It's actually matching the results from those tests, and we are obviously third-party certified and those certifiers will go to our sawmills and review all our processes, review our documentation, review all the testing, take samples, random samples every now and then. They do their own testing and then make sure and ensure that our products are actually complying with Australian standards. So that's, a little bit of a summary of how we produce structural graded timber and what will be the different roles that an engineer and the quality guys will have in a sawmill to be able to control the production of structural graded timber. In order to use these materials, so we have different structural typologies, and I'm going to focus especially on light timber framing. So obviously timber can be used in different systems. We can have, again, the traditional light timber framing systems that we use in residential housing, but we can also use light timber framing for multi-residential construction or mid-rise buildings. We can have posts and beams, which is very common in glulam. We can have trusses. We can have solid panel constructions when we use CLT, for example. So yeah, there are many different typologies. But again, I'm going to focus on light timber framing. This is what we produce, and this is where 80% of the timber that we produce in the country goes to. Again, you've seen this before. This is mostly the system that is being used in residential construction for one-story house and two-story houses. There are different ways of building these houses. You can build it on site, like stick builders do, or you can prefabricate all these frames and trusses and then send it to site already done. If you start adding other parts like cladding or windows or insulation, then you increase the level of prefabrication and then you speed up the construction process. And obviously, light timber framing can be also used in multi-res buildings with DIN 255 solutions that comply with the national building codes. These days, you can see that there are very high levels of prefabrication in some of our customers' plants, where we send all the timber and they have all their designs, and then they use CNC machines that are pretty much robots that pick up the timbers. They have automated pickers that select the different timber boards, and then they start producing the different elements, either walls or trusses based on those designs. And finally, you ended up sending those jobs like pretty much ready to install and really speed up the construction process. So I have this is a video from one of our customer partners located near the Colac sawmill, where they have a very automated process for manufacturing these frame and trusses. So it's actually quite interesting to see how this prefabrication has advanced in the last few years, which makes this typology and this system very competitive when you do mid-rise buildings. So you can see there that all the parts have been already cut to the final dimensions, and then you have robots that will locate nail plates in this case, but you can do it also with nail guns and other sort of connections, and they locate it in the final position, and then you press it to the right conditions, and then you pretty much can build a wall or a truss in few minutes without any sort of human intervention. So that's really cool. Obviously, you can use light timber framing for mid-rise buildings. And again, it's important to engage with the designers as soon as possible, but also engage with the manufacturers to make sure that everything is accounted and that you address critical issues like fire and acoustic performance, and obviously the procurement of the material and the logistics for the dispatch of the different parts, so you can speed up the construction. But Obviously, there are other types of materials made out of timber. Engineered wood products are very common these days. So there are many types of engineered wood products depending on the way that you process the logs. As I was explaining before, so you can cut the logs and have boards, and then with those boards, you can glue them together and create glulam. Glulam is just a glue laminated element made of different boards that are all oriented in the same direction, whereas cross-laminated timber, as you already know, it's consecutive layers of timber that are perpendicular to each other. And CLT is very useful for floors and walls where you have, like, when you want to cover surface areas, whereas glulam are prismatic elements that are very convenient for beams or posts where you just want to transfer the load in one direction. But then if you peel the log and if you have very thin layers of timber or veneers, then you can produce materials like plywood, which is layers of veneers, perpendicular, like glue perpendicular to each other, whereas in LVL you have all the layers and all the grain or the fibers oriented in the same direction. And again, that's why LVL is very common in beams and studs as well. For those that are not familiar with the production of glulam or CLT, well, this is all very similar to sawn timber up to the grading part, but after you have the material that is already graded, then you need to finger join those boards, because usually glulam beams are larger than 6 meters, which is usually the length that you get out of the logs. So if you want to make longer elements, you need to finger jointing those elements and then plan the surface, prepare the surface for the preparation, for the application of the glue. And then after the glue is being applied, you press it, and then you create those bigger sections that are later cut by these CNC machines. And then finally you package it and send it to the construction site. So I had the chance, before working at AKD, I had the chance to work in an engineered wood company producing glulam and CLT. And one of the things that is important to mention is that the application of the glue or the adhesive is key for the correct performance of those materials. The right performance of the glue, it's critical, and we need to control many different variables. Some of them are related to the wood properties, like what's the density of the wood, what's the moisture content on that wood. Some others are related to the processing, like how is the preparation of that surface for the glue application, and what are the dimensions of those elements that you are putting together. Obviously, the adhesive plays a massive role as well, and then other application factors like glue rates, glue spread, curing times, assembly times, or pressure are very relevant. So this is really critical and part of the role that the engineers will have in those factories, are controlling those production parameters and making sure that the glue lines perform well. But also you gotta do a lot of testing, same as you do testing in the feedstock at the sawmills, where you predict the properties and then verify that those properties are actually the ones that you are declaring. You gotta do the same with the engineered wood products, glulam, CLT, LVL, they all need to be tested, and you need to verify that those properties that you are declaring are the properties that you get. And then you create models, and then based on those models, you need to confirm that whatever you predict actually matches what you are getting on your test. And then obviously having same QA systems where you control the quality of the glue lines, where you control the quality of the finger joints, where you control the mechanical properties of the elements that you are producing. Another very important role of engineers in this industry is the design for manufacturing and assembly, or also known as DFMA, where you pretty much design each individual part, and then you ensure that those elements are manufacture to a very strict tolerance, because when you send those elements to the construction site, then you need to make sure that they fit really well and that those tolerances and those properties are actually the ones that you have designed with. So this is a project that we did in my previous role. This is the design. This is a second floor that was installed in top of a concrete floor. You can see all the different panels, CLT panels and glue lamp. And this is, some photos during that manufacturing process when we did all the QA processes, when we verified that all the dimensions were right, when with the CNC machines and the robots, creating all the make all the holes and make all the prepare the elements for the connections, and then we design and plan how those panels were going to be loaded and in which order we're going to be loaded to be able to make the construction more efficient. So this is all part of what an engineer will do on planning that construction phase, and then obviously delivering those elements to the construction site, making sure that they're all installed accordingly. And this is how the end product will look like. Photo on the left-hand side is the photo of the architectural renders, and then on the right-hand side, it's how the construction ended up looking like. And one thing that I also wanted to mention is the obviously by using engineered wood products, we can now achieve, higher buildings, and we can build higher buildings. And we know that timber is being now used for mid-rise buildings up to 20, 30 stories, but this brings additional challenges, particularly for fire safety. So this is, part of what I did in that role was also going through testing program and understanding the performance of the material. And I know that you guys at UQ have a group that is dedicated to fire, which I had the pleasure to be part of. And we know that there are many things that affect the performance of those panels, and it's not necessarily something related to the fire resistance, but there are many other things like fire growth and fire contribution. So this is a photo of the test that we did when we were testing this material after 120 minutes of testing on a furnace test with a loaded floor. This is how the test looked like when we finish it. So yeah, well, I tried to cover as much as I could, but then my last slides just give you a glimpse of what the future needs in this industry, I believe. So we need to better understand the properties of our resource and what will be the impact of that resource in the sawmilling. So for example, we process a lot of softwood from Queensland, and that particular fiber has a lot of resin content, and we really want to know and really want to understand what are the properties of those logs, what are the properties and how those properties will impact the recoveries at the sawmill and the characteristics of the products that we produce. We feel that we need to expand the deemed to satisfy solutions that we currently have. We can only use DTS solutions for 1 and 2 story houses of a particular size and a particular height, and we need to expand that to be able to reach other markets where timber can be used, but it's not currently used because the certification process and the design process is too complicated. So we need to expand that scope of the current standards and make sure that we can use light timber framing and in mid-rise buildings. Obviously, our design standards have issues, and the more that we research on the properties of the timber, the better we can address those issues. So, and then we need to better use the fiber that we have. We are constrained by the fiber that we have available in the country, and that's where we need to have imported timber. So we really need to make the most out of the fiber that we have in Australia. So we need to better utilize those resources. We need more digital tools. We need to improve the quality of the timber, improve the quality of our treatments. We need to develop appropriate engineered wood products for our fiber, and then use modern tools like AI to optimize and leverage from the data that we capture in the forest, in the sawmills, in the construction site, in the marketplace. So yeah, well, I hope that these have, give you a good understanding of what engineers do in a sawmill, and yeah, I'm more than happy to, answer any questions.
Are we muted now? No.
We are not. So
Thank you, Mateo, for your presentation. I think maybe there will be some technical questions, but before that, I would like you to put the cherry on the cake, and then this is a meeting for students, and I'm thinking about them. So can you briefly explain, because you cover a wide range of things and the needs for the timber industry, but can you briefly explain what is your daily task, or how a day in the life of an engineer working in timber looks like?
Yeah, again,
Students can
I try
expect
to
from a job like the one that you have.
I try to cover many different topics because engineers can work and timber professionals can work on many different areas. From quality roles where you control the properties of the timber, make sure that the timber is compliant, work with the guys at the sawmills, trying to control the quality of the drying process, the quality of the sawing, the verification of the mechanical properties. So that's for people, involved in quality control. They do a lot of that, and I did a lot of that in my previous role, making sure that all the products that we were producing were compliant and that we monitor and control all the production parameters. But if you're working in a design area, if you are designing timber buildings, you're going to be involved in, working with the architects, working with the builders, working with the structural engineers, doing all the design of your members, specifying different timber products, calculating all the loads and all the spans, and working with the design team. My role at AKD these days, it's highly focused on R&D and sales. And so I visit our clients, I talk to the end users, I try to understand the way that they are using different products. So I go and check, why are you using this product here and there? Why is it better to maybe to have a more efficient use, to replace this size and this grade for that one, but also trying to bring those ideas to our sawmills to say, well, should we, instead of producing this product, change it for that one, because that will be a better use of the fiber that we have. And then working with universities. So I'm spending time with some of the faces that I can see in the call, like the guys at UTAS, or the guys at UQ, setting up projects that we feel can bring new ideas to the table, and then can end up, creating new products. So it ranges from many different things, and for people like Marina that was here before, she's a timber specialist and she spends a lot of time in the treatment process, for example. So ensuring again that the timber is treated properly, that we are using the right chemicals in the right proportion, to make sure that timber structures are durable and that last longer. So again, very, very wide range of options, and they're all valid.
Thank you, Mateo, for comprehensive answer. So, yeah, go for technical questions.
Yeah.
Or
Hi, Mateo. Thanks for for your presentation, very thorough. So for those who can't see me, I'm Thomas Bravo. I'm a PhD student at UQ. We'll talk about Paula's question first, and then I'll do mine. So Paula asked if in a resource-constrained construction future, reclaimed timber can be considered for manufacturing. What's your view about opportunities, barriers of this pathway? In particular, how could quality be tested compared to what you do now?
I think so. I mean, there is a chance for using reclaimed timber in a sawmill. It will have to go through the same grading process that we pass, our normal timber. After timber is being dry, it will have some dimensions and some properties, and then we need to grade it based on the thresholds that we have to meet Australian standards. So if you really want to reuse timber and if you want to put it through the same process, I think you can, but that will require a specific process and a specific line to do it. It will be hard to do it with the way that sawmills are set up at the moment. This is a high volume production where any sort of disruption or any changes in the normal process will have a massive impact in the volumes that we produce. So yes, there is room for that, but we will have to create a specific production process for that, for sure. No worries, Paula.
So thanks, Mateo. Before Wenchuan's question, I wanted to ask a question in the same line as Paula. So you stressed a lot on how Australia is a net importer of timber, and AKD as a sawmill and forest plantation owner. How's the growth in terms of forest plantations areas in Australia at the moment? Is it growing? Is it stagnant, or is it decreasing?
It's I think this is not my area, but from what I've seen and what I know, softwood plantations have been steady and actually slightly decreasing in the last few years. We are really pushing for that to change because we know that we need more timber. AKD only process like around 10% of what AKD process is AKD owns plantations. So most of the timber that we process comes from state forest or private forest. And the plantations that we own are spread all across Australia. So we need more plantations, that's for sure. If we want to meet, the targets that we have set, we need more timber. And again, that's why we are trying to, and this is not only AKD, but guys in Utah are, and the guys at UQ as well. They are looking at projects that are looking at different resources, not only plantation softwoods, but other resource that is already out there, like some Australian hardwoods that have been traditionally used for paper pulp production. How can we utilize that material that is already out there to actually build more houses?
Yeah, thanks for that. So Joe Garas, me, and Kim Baber and Keith Cruz just came back from Chile, and the issue over there is the exact opposite. So Chile is a net exporter of timber. They export some to Australia. And yeah, the challenge over there is to find a use for timber because it's not as widespread as a construction material as it is in Australia. And it's funny to say it that way, to see how two similar countries are having the exact opposite issue for the same industry. Yeah, so Wenchuan had a question as well. a couple of questions. First one, you mentioned about the sapwood, that it has higher stiffness and density than hardwood. If you could comment on that. And then I'll go up through the other questions.
Yeah, so when we cut the logs, usually what we call the can is what the middle part of the board is. That part is obviously closer to the center of the log, and that juvenile wood, when the tree is growing, that wood grows very quickly, and that makes that timber is less dense than the timber that is in the outer part of the log. So, and there are other things that may affect the performance of the material as well, like the peat. So usually that timber doesn't meet the thresholds for density and stiffness. And a lot of the timber that is located to the near the center of the log ended up going into packaging material, because we cannot use it to produce MGP grades. So part of the projects that we have as well is how can we better utilize that fiber that doesn't meet those requirements, that fiber that comes from the center of the log near the pit where the hardwood is, and hope that explains that.
Yeah. Then his second question was about the characteristic values. So why is the 5th percentile representative of strength and not the average?
Because strength deals with capacity. So when a material breaks, we want to avoid that at all cost. We don't want anything to break. Whereas stiffness and MOE is related to deflections or deformations. So even though material deflects more than what we want, the consequences of having more deflection are not as bad as breaking. So because of that reason, we want to make sure the timber is a natural variable material. So it's going to be really hard to define one value. We're always going to have a range. And out of that range, we want to make sure that 95% of almost all the materials are above that declared property. And that's why we use the 5th percentile, just to make sure that like a large proportion of that population is always above that value. Whereas in stiffness, again, because the consequences are not as critical as in strength, we can use the average, and we know that part of that group, part of that population is still below what we have declared.
Thanks for that, Mateo. And then Wenchuan's last question is about preservatives. So he noticed that, you showed a picture of a lightweight timber framing house or whatever that was blue. So is treatment required regardless of the use of the structure? And what are the preferred treatments in industry, as far as you know? And does it change for mid-rises?
Yeah, well, the type of treatment that is required depends on the type of exposure you have. So the Australian standard has classified timber exposure to different levels. We have H2, which is a hazard level that timber needs to withstand termite attack. And then we have two different types of H2, H2F, which is above the Tropic of Capricorn, below Tropic of Capricorn, and then H2 above the Tropic of Capricorn. The H2F is blue, H2 is red. So because those termites located above the Tropic of Capricorn are more aggressive, So that's why they need different type of treatment. H3 is when the material is can be exposed outdoors, but above ground level. And then H4 is when it's below ground level or in contact with soil. So the type of treatment that you select and the type of chemical that you use in your timber depends on the exposure that you have. And not all the timber is exposed to termite, so they don't require that treatment, not necessarily. So you still see a lot of houses that are built with untreated timber, because again, they are not exposed to that hazard level. And but if you are, if your structure or your building is going to be exposed to water and termites and borders and so on, then you need to treat the timber to whatever level is required. And then for different type of treatment, then yeah, you see CCA, LOSP, and assaults, but yeah, this is not my area, so sorry, I probably won't be able to answer that.
Yeah, no, thanks very much. And I think we have a last question from Josh. Do you want to ask it yourself, Josh, or do you want me to read it?
Oh, yeah. Oh, no, I was just going to say, obviously my area is fire safety, so not really across any structural areas. So I was sort of just asking, what are your thoughts on what are the limits of actual timber with respect to engineered wood products? We're not going to be building necessarily high-rise buildings out of it, but do you see a future in which we're creating lots of hybrid structures? And where do you see the use of timber in 20 years, and what are the most important areas of research, in your opinion, to be able to get there?
We're already doing it. You're already seeing it in Australia, in Brisbane, in Sydney, in Tasmania. Mass timber buildings being built. We're currently building a 40-story building in Sydney, the Atalassian, I think is the name, which is a hybrid structure made out of steel and CLT and glulam. We've seen already approved designs for a 50-story building in Perth. So it's happening. Are we, 100% ready? Is it everything known? And it's a more philosophical question. In terms of compliance, yes, you can demonstrate compliance somehow. But have we answered all the questions in terms of, lateral stability, energy dissipation, fire spread, fire performance, fire safety, durability? I think we can safely design those buildings, but in a very conservative way somehow. There is way for increasing the efficiency, to better use the materials, to make those structures even safer. There are still a lot of gaps in our current standards. So a lot of the work that we need to be putting in the next few years is bringing Australian standards up to speed, up to the level that European standards are. Having more local manufacturers as well, because a lot of the timber that we use for those high-rise buildings is imported. So I feel that our local manufacturers need to, and we already have some, but we need more. If we really want to keep, exploring that market, we need more. We need more competition. We need to be able to deliver local products to improve the sustainability credentials. So yeah, a lot of work needs to be done to do that.
Thank you, Mateo. Any more questions, people in the audience? Huh? Yeah, so we're running out of time. So thanks everyone for coming. Thanks, Mateo, for that great presentation, and keep an eye on our social media. Well, Nathan and Utah's guys, we have a meeting pending still, but keep an eye on social media because a lot of things are coming with this new student chapter, and we'll be getting more presenters and more ideas. We're open to hear from all students in Australia to get better presentations and to make this community grow from students up to people like Mateo. So yeah, thanks very much for attending, and we'll see you next time.
Thank you, guys. Thanks for having me.
Thank you.
Bye.